So do we have to stand at the lectern, or can we wander? We can wander. Okay. I'm going to wander like a crazy person, and I hope you guys are all awake. And I was thinking about doing the really awkward thing of asking everyone to come forward, but I know that as soon as somebody asks that, you want to murder them. What we're talking about is actually nice to hear from Sanji from Optum, because that's until a year ago, I had been at Optum working as a data scientist, primarily on Medicare Advantage, ACA, and Medicaid models. And what we were trying to do is we were trying to predict chronic conditions. So we'd chew through the claims data, the lab data, the pharmacy data, and all these types of data sets that we'd get from our payer clients to do one of two things. One was trying to predict the chronic conditions that members would have, because as soon as you can predict chronic conditions that a member has, you can get paid more as the health plan. I mean, that's how the federal government works. If all of a sudden I see my boy Frank here, and Frank, this is not prophetic, I hope, cross fingers, but if Frank turns 65 and all of a sudden he gets severe diabetes, all of a sudden his health plan is going to get paid, many thousands of dollars more to take care of him. So, Frank later sacrifice whatever goat you have to whatever pagan deity to ensure that you don't get diabetes. So when we think about now having moved to Clarivate last year, we're working on solving different kinds of problems for people. We have one of the largest databases for medical and pharmacy claims. We have EHR data. We have a bunch of different healthcare data sets. And when I came in, it was a little bit different because we started to solve problems, or we were already solving problems for pharma entities, medical device companies, payers, provider groups. But for the biopharma clients, they're primarily interested in how do we deploy our sales teams so that we can go capture as much revenue as possible. And that was the central question. And so what I want to attempt to walk everyone through as the timer slowly dwindles is how I think people start going about solving these problems, how I would have started solving these problems when I was fresh, dewy, starry-eyed grad out of undergrad, and how we try to approach those problems now. And out of curiosity, how many people in the room are data scientists? You got 1, 2, 3, 4, 5, 6, 7, about 10 or so. And anybody else, everyone else pretty far outside of the data science, analytics space, leaders, commercial guys? Okay, so I hope this speaks to you, because what I'm trying to get at is when companies make the large investments on artificial intelligence, and be that standing up SAS or hiring a bunch of PhDs out of Stanford or something to solve all of the problems, I think that what happens is that people make these investments under the assumption that they are dealing with sorcerers. And data science is not sorcery. It's not magic. You don't wave something. You don't wave a wand, and all of a sudden you have the answer that you're trying to achieve. It is it's methodologies, and hopefully you have data scientists that can help walk you through what are the trade-offs as you pursue predicting what you want to predict. So I'll give you an example just to put in the back of your mind, and then we'll walk through the journey rather rapidly. The big question that we get often from people is how can I get better intelligence on my competitors? So if I'm Abbott or Medtronic or Pfizer or AstraZeneca or something, I want to know who's doing procedures that I care about, who's doing knee replacements, and then in the market, and where's the opportunity, where's the meat on the bone, and secondarily, where do I have a threat? Do I need to be worried about somebody coming into Memorial Hermann in Texas and selling their fancy new Stryker knee device, and I've got no intelligence on it? So let me go forward a little bit. Anybody read any of these books? Doesn't ring a bell to anyone? Got one? Got two? So these are some of the books that you might get if you do a 3-day session that your company pays for data science, and you walk out of that with a certificate feeling like, man, we can really do this stuff. That feeling that you had when you walked out of that is the same feeling that every undergrad has. This is me in the middle of undergrad. Admittedly, I didn't have a lot of pictures from college, so that's at a Model UN conference, which is not a conference for models that attend the United Nations, just in case anyone is wondering that. Mock UN. So when you're in university, a lot of what you learn is you say, you jump into Stata. Maybe your school is using Python, but you just walk through with your professor all of the different methodologies that you can use. LPM, logistic regression, linear regression. Maybe you start using TensorFlow. Maybe you start getting really excited about these different methodologies, and you get walked through with your professor these very narrow use cases, whether it's your end of term project or whether it's just some project during the semester. You're existing in a laboratory environment. Everything's very controlled. Your data sets look great. Your professor has already done this a million times over the past 20 years or 10 years, and you get this pretty big overconfidence that you can go out after you graduate and solve all those problems. You can lay that model on something, and you're going to get this perfect output. You can predict anything, or conversely, you can say what exactly. You can say why stuff is happening, and we'll get to that a little bit later. So you get into your first company, you jump in, they hire you. You're all excited because you can throw logistic regressions at anything, and they throw you into the deep end. They give you your SQL Server login or your Snowflake login or your Redshift, and you start jumping into the data. You never touched SQL in school. I don't know if this is representative of everyone, but this is at least representative of what happened to me. Then they need you to become a database engineer. They need you to become expert in Python or SAS or R or whatever happens to be the de rigueur tool for the organization. And pretty quickly, you get shellacked by every salesman or ops leader or executive leader in the company saying, I need this, give me this data, give me this data. Is that the experience that anyone's had here? Any of the data scientists, analysts? That dude over there. I'm hoping this experience is not as unique as it seems like it might be. So you learn a couple things, and this gets to the trade-offs that we think of between data, what data you have as an asset, what models you have at your disposal, and the domain expertise needed to interpret those models and even generate the necessary theories or hypotheses that undergird your models. When you're an analyst, people come to you and they say, I want this, I want that. I want all of the heart surgeries that occurred from 2016 to 19. And you start getting into this pattern of becoming a data jockey. You give people reports, you're waiting, hey, when am I going to do something cool? You start answering these summary statistics questions that people throw at you. What you learn, hopefully soon, and this is where the relationship changes between the analyst or data scientist or whatever your title is in your company and the business requesters, is you learn how to ask those questions back to the requester. If I'm a sales guy and I'm coming to the analyst and saying I need whatever the example was, the heart surgeries that occurred in some year, then there's an actual question that the client has. There's an actual objective that is trying to be reached. And as you cultivate your data science team and your analytics teams, the questions that should begin to come back are ones that allow the analytics team and the data science teams to do the questioning and to do the actual science, rather than having the requester do the hypothesis testing. And I apologize if that's not exactly clear. What I mean in summa is that as you get more sophisticated, you as the data scientist or the analyst, you start asking the necessary questions rather than relying on other people to give you the right questions to ask. And that's a key thing. And that's something that we have to deal with on a daily basis. When our clients come to us and say we want to know how we can better capture the market for I don't know, lumbar, spine, surgical devices. We have to figure out what are the core objectives behind that question. So A lot of companies, they make big investments, big investments in the data science team. Sometimes that's just to engender investor confidence. They're trying to raise the stock price. They're trying to get people excited about having a data science team, and they think it's going to be great. But what I just described is what eventually has to occur, is a marrying between the leaders, the business leaders in the company, the sales teams or the ops teams or what have you, and the data scientists in the company. Is anybody? Oh, we're using the old presentation. Anyone in here remember the equation y hat equals alpha plus beta hat x plus epsilon? Anybody remember that equation? Got some in the back, and that's how we estimate a dependent variable. This is something that data scientists and econometricians that get hired into a company. This is something that they have to keep at the back of their minds. And there's a big difference between academia and business. In business, people care about y hat. They care about the thing that you're trying to predict. They care about where the knee surgery is happening, where the heart attack's happening, where is this happening. They care about the likelihood of some event to occur. In academia, or any economist will tell you that what they care about is the causal story behind that, or beta. If you remember your elementary school or middle school algebra, y equals mx plus b, the economists all care about m. They care about the coefficient. What's the effect? If I eat a bunch of tacos and ice cream, what's the effect of the tacos on how bloated I am versus the ice cream? I'm guessing no one's had that experience based on the looks that I'm getting. But that's what economists care about, and the thing that's important about this as you bring data science into these business questions is you need to have a plausible theory or a plausible causal story as you start to bring in your variables in consideration for your model development. So as you do all these things, as your data scientist or your data science team becomes attuned and they go through this journey, they begin to help you generate the insights necessary. Rather than being order takers, they're coming to you and saying, "Hey Jeff, what about this? We need to ask the client this. We need, if we're going to predict this outcome, we're going to need these types of data sets to flow into the model." They'll get very familiar with all of the methodologies. I don't know if anyone else has experienced this. I confess, I've been in the position where someone says, "Hey, what do you think about this?" And I just say, I'm going to have to think about it, but I think it could possibly be a good plan, because I just, at the time, 6-7 years ago, I wasn't sophisticated enough. I hadn't learned enough, but I still wanted to look like a smart guy. I'm sure no one's had that experience. The technical skills. As you become a data scientist, you have to do, everyone's been there who's done this, but you have to become your own data engineer. You have to be the one. It's not like school where they give you the perfectly curated data set and you can just hit I can't remember the function. You hit logit on that thing and you're gonna spit out your output. You have to be good at manufacturing your own data sets, which feeds into the knowledge of what data do you need to support your model. And finally, and we haven't touched on this, but it's key in that triumvirate or that trifecta of trade-offs, is industry knowledge. I've been in healthcare since 2004, since 2004, doing analytics and data science. When I got in there, I didn't know the difference between Medicare and Medicaid. I looked at a medical chart and I had no idea what any of the values mean. I didn't know anything about the incentives that would go into medical coding, for example. And brief 5-second example of that is industry knowledge. If you're trying to predict who's likely to have a heart attack, well, guess what confounds your model? if you're expecting all that the medical chart reflects truth, then you're going to be in a bit of an issue because doctors and providers have an incentive, may or may not have an incentive to code up, which means if they think, if you come in and they say, hey, this person has a mild COPD, if they in an attempt to bill more dollars to the health plan say, actually this person has severe COPD, then that's some industry knowledge that you would want to be able to contemplate as you develop your model, so you don't believe that all these people, how come all these people with severe COPD have a lower than expected incidence of heart attacks? Industry knowledge is key. So back to the trade-offs that we're getting to, and at the risk of being a naked promoter for data, you have these three things at your disposal. You have how do you apply data science? So where is the artificial intelligence, the predictive models? Where is that valuable, and where do you want to apply it? Where do you want to spend the money? Secondly, what's going to be the cost of the domain expertise required to build accurate and predictive models? That's something, when I was at Optum, we had a bunch of MDs and specialists that were on our staff as we went to go build our models because we couldn't independently look at all of the medical data coming in and say, oh, well, this should be associated with this, or this is actually, despite the fact that you see these two conditions, they're not actually comorbidities, and it's just an artifact in the data. That's not something you would ever know unless you had the medical doctors weighing in on the development. The last thing that really relates to Clarivate is the data to undergird your models. We see this time and again. We see the overexcitement, the over investment perhaps, or over exuberance of throwing AI at everything, like that magic wand, thinking that it's going to solve all your problems. But as somebody somewhat steeped in the arcana of data science and econometrics, and having done this for long enough, what I value more now than perhaps I ever had was having the right data and spending the time to go and acquire it from whatever sources are possible, whether it's a data vendor, whether it's going to hire somebody to do the surveys on patients, or really anything to acquire the necessary data to feed into your model. That's the last piece that now I tend to value more than anything else, because any statistician or data scientist will tell you, as you start to go into the predictive realm, you're somewhat out on a limb. You're hoping that you have enough data that your predictions are going to be externally valid and applicable to new data sets. But if you can bring the right data up front as an input, it makes your life immensely easier down the road. And I'm over time, so thank you very much for having me and paying attention. And to everyone that left, I'm very sorry for not interesting you.